All right, boys and girls, welcome back to the drive-through for a little 5-minute lesson on 10-1. So this is circles. You guys know a lot about circles. Vocabulary. Some of it will be review, some of it will be new. Central angles, and I'll give you a little introduction to inscribed angles because I think it makes sense to do them both at the same time. So what I'm going to do here is going to go over all of these vocabulary terms one at a time. That's a circle. It's 360 degrees. That's a circle. It's 360 degrees. The measure of this yellow arc in degrees is 90 degrees. The measure of this yellow arc in degrees is 90 degrees. But the lengths of these arcs are not the same. Okay, so the arc length is the distance traveled in a curved path along a circle between 2 points on that circle. So there's your arc length. Whereas arc measure, we can measure in degrees or radians, and we'll get back to those in just a little bit. Okay, you just saw an example of a central angle. A central angle has the vertex at the center of the circle. That's pathetic, so I'll do it again. That's better. And I'll go ahead and ruin the movie for you. Whatever this angle is, so is the measure of the arc. So that's called a theta. The measure of the central angle is the same as the measure of the arc. And that should be fairly intuitive. If you think about like what a 90-degree angle looks like, that's going to be 1/4 of the circle, which is 90 degrees. If we draw a 180-degree central angle, the measure of the arc that it intercepts will be 180 degrees. An intercepted arc, we've already drawn a number of these examples, but it would be the arc that is intercepted. So this, I'll show you two things. This is called an inscribed angle. And its intercepted arc I will put on here in pink. So it's the arc that is intercepted by an angle that is inside, on, or outside of a circle. Okay? If you're wondering, the relationship between an inscribed angle and its intercepted arc is that the angle is now half of the arc. The arc is twice as big as the angle. Okay? A major arc and a minor arc. A major arc is greater than 180 degrees, and a minor arc is less than 180 degrees. So if I had these, a minor arc might be arc ED. That'd be a minor arc. It's less than 180 degrees. Where the major arc I would indicate with 3 letters, and that would be END. Well, why did I let's use pink. And that would go from here through N all the way to D. So we've hit minor arc, major arc, intercepted arc, central angle, arc length. So, okay, we got 3 more big pieces of vocabulary. A radian. It's going to take you guys months to kind of understand a radian. Let me give you 2 places to start. A radian is the measure of an angle along a circle that is the same length as a radius. So if this was 6, this would be 6. Okay, now what does that mean? Well, that means that 2 pi radians are the same as 360 degrees, because to find the circumference all the way around the circle, we do 2 times pi times the length of our radius. Another way to think of that is that pi radians is 180 degrees. Pi over 2 radians is 90 degrees. pi over 3 radians is 60 degrees. Pi over 4 radians is 45 degrees. Pi over 6 radians is 30 degrees. And if you have any older brothers or sisters, or you're friends with people that are in pre-calc, you'll notice all of these are on your unit circle. These become important measurements. Okay? Bless you. A sector of a circle is a piece of pizza. So it's an area of a circle formed by the central angle. Now, does that look like a 90-degree angle? It does to me. How would I find the area of that piece of pizza? I would just do 1/4 times the area of the circle, right? So the sector area formula does not need to be memorized. You should remember it. You should understand it. You take your sector degree and you put it over 360. That tells you what percentage of the circle we have, and then you just multiply it by the area of the circle. Okay? So you definitely need to know that, but I think it should be something you kind of understand. The segment of a circle. Well, this is a very strange piece of vocabulary. I've always thought that. The segment of the circle is the sector minus the triangle. So it's basically like the crust of the pizza. That is called the segment of the circle. So the segment area is the area of the sector minus the area of the triangle. Okay? And honestly, we don't have a whole lot more time as this is a 5-minute lesson, but that's all of the new stuff for this section. All right, so we'll move quickly. Find the area of this sector. Okay, well, it's a 78-degree angle, so this area would be 78 3/60ths. I've got some serious dyslexia today. Times the area of the circle. Well, the area of this circle is going to be pi times 10 squared, which is 100. Okay. Okay, we had a little technical difficulties there with the audio, but here's how you do this, okay? I don't know if I already wrote this up here, but it would be 78 over 360, this is the area, times pi times 10 squared. And you end up for that getting 68.06 square centimeters. Don't forget your units. Let's look at another example. Oh, the area of the segment. Okay, so now the segment is going to be the area of the sector. Here goes. Minus the area of the triangle. Well, I'm telling you right now, the triangle is going to be hard for many of you guys. You struggled with this during the triangle section, so it's okay. Just take your time and get help when you need it. Well, the sector is going to be 60 over 360 times pi times 8 squared. Okay, so for that, just use the pi button on your calculator. You get 33.51032. 5102, 5103, 510032. Okay, now the area of the triangle. Well, I'm going to need a picture for that one. Notice these are the same. So it's at least an equilateral triangle, but this is 60, and they have to add up to be 180. So this is an equilateral triangle. You got 8 here, 8 here. This is why they call it a special right triangle. Look, 4, 4, this is 4, radical 3. Remember that? Remember that? Remember that? So the area is going to be 1/2 times 8 times 4 radical 3. So 16 radical 3. 27.7128. And so then the segment area would be the sector area minus the triangle area. I got this all in my graphing calculator, so now I can just do that minus that. It's so much easier. And the segment area is going to be 5.798 square centimeters. Okay, that's some challenging problems. That's a lot of vocabulary. I hope this helps. Boom.